Hey guys, this is video 5.2, our notes on how to classify bonds. We're going to kind of just go through general pieces here of the different bond types, kind of what's going on with those. Make sure you know each type of bond, what makes them unique, how to identify them, and the pieces that go along with those, because it's very, very important before we start to actually draw those bonds. So let's just jump right in and get to it. We're going to be on page 7 in your notes. So we're going to talk about 3 types of bonds today, but really one of them we're not even going to discuss, and that's metallic bonding. We're going to kind of just put the definition out there, so make sure you are familiar with it, but it's actually not going to be anything that we draw in the next upcoming videos or really worry about too much. But we'll get there when we get there. So the first one that we're going to talk about is an ionic bond. And how we know an ionic bond from the other types is that it's formed by a transfer of electrons, and that's the biggest thing there you've got to remember, is that word transfer. So we're going to, as we go through this video and as we're going through all of the notes here in this unit, I'm going to really drive home that key word of transfer. So make sure, if nothing else, about ionic bonds, that you know that it's a transfer that's taking place. So and that's going from one atom, or what we call a polyatom, we'll talk about in a minute, to another. So the classic example that we see here is listed in A, where you have a metal losing its electron to a nonmetal. So based on the periodic table, excuse me, and the valence electrons that you guys studied in the last unit, should make sense, right? Metals have like 1 or 2 or maybe 3 electrons, and it's easier for them to lose their electrons than to gain 6, 7, 5, 6, or 7 more. So they're very willing to lose those. And that's exactly what we see here. Sodium is actually going to give up its electron and give it to something like chlorine, which is a nonmetal that only needs 1 more electron. So they're a perfect match made in heaven there for those. So sodium chloride, that's exactly what's happening. That's kind of the first way to kind of look at it, is look for a metal and a nonmetal. So when we have an ionic compound, to classify it, the easiest way to think about it is look at what elements do I have. If I have a metal and a nonmetal in the compound, then I know right away it's going to be an ionic bond, because one's giving, the other one is receiving. The next type is what we call, is the same thing, but it's where a metal combines with what's called a polyatomic ion. Now, we have not discussed those yet. In our next unit, when we start naming compounds, you've got a whole list of polyatomic ions that you're responsible for knowing, but we'll talk more about it now. The biggest thing you're going to see with a polyatomic ion is they've got parentheses around them. Think about it. If you break the word down, poly just means many, okay, or multiple atoms. So in here, you can see in this bracket, you've got multiple atoms. We've got 3 oxygen atoms, and we've got 1 nitrogen atom, and it's making up an ion. Okay, so again, we'll see the whole list. For right now, just be able to recognize them. That if you see something like this where you've got charges, think, again, ionic compounds have that keyword ion in there, so they're going to have ions. So up here in A, the metal becomes a cation, and the nonmetal would become an anion. Okay, so you always have ions that are taking place, and you'll see those in the structures themselves. So same thing here with that metal and a polyatomic ion. You could also have a polyatomic ion combining with a nonmetal. Again, you're going to see the charges on both of those. Okay, so that polyatomic, again, many atoms making up a single ion, so it got a charge around it. You're going to see them, especially when we draw the structures for those polyatomics, they're going to have brackets around them, and that's really important. So as we continue on and we start drawing, we'll talk more about why that is and why it's so important. So now, again, just keep looking for those charges. If you see charges there, you know it's going to be an ionic compound. And the last type that we could have is still, again, a polyatomic ion, and it combines with another polyatomic ion. So again, the key word here in all of these is that you're going to see ions, and that's where we get that term ionic from. Okay, so look for those ions. We're going to get into the details of how to draw these structures as we go on throughout this whole unit. But for now, we're just trying to classify them. So ionic, classic way, is metal and a nonmetal. So make sure you know where those are and kind of what separates those on the periodic table. The other thing is, if you see ions, you know it's going to be ionic. Okay, so the next type of bonding that we're going to talk about is what's called covalent. Now the big difference here is that you have compounds being formed when you have two or more nonmetals. So notice there's only nonmetals here in a covalent compound, and they are sharing their electrons. Okay, so you've got ionic compounds that are, or ionic bonds, I should say, that are transferring electrons, so one gives, the other one takes. Here with covalent, though, you are sharing the electrons. So again, you have two or more nonmetals. Okay, so that's a big difference there as well. You only have nonmetals. So something like methane, where, oh look, I've got all these different nonmetals, they're sharing the electrons. There's not a give and a take that's there. So if we kind of go through and look at this table, just very briefly, if I see a metal with a nonmetal, kind of the classic, that's why it's in bold, I would star these two. They're going to be the most common ones you're going to see. Metal and nonmetal is ionic. Metal with a polyatomic ion is also ionic. A nonmetal with a polyatomic ion, ionic. Ion and ion is going to obviously be ionic, and then a nonmetal and a nonmetal is going to be your covalent one. So again, the top and the bottom are going to be kind of the most common things you're going to see, but just be on the lookout for those polyatomic ions. And again, as we get into naming in the next unit, you're going to have a whole list of polyatomic ions that you don't have to memorize, but you've got to recognize them. So it'll be a lot easier when we get into that. And we're going to just mention here again, metals, so metallic bonding is a thing. It's something we're not going to draw, it's just there. So if you think about something like if you're on a bridge and you see a big thing of steel, you've got metallic bonding that's taking place. So metals are pure substances that are found to the left of the staircase. Again, that's a review, you should know that already. Atoms of metal do not bond with other metal atoms. They share a sea of mobile electrons. So hopefully you remember that from the last unit. What this does, though, is it allows metals to conduct an electric current because those electrons are moving freely. So that means like they're really good conductors for electrical energy or heat. Okay, and it's because of those unique mobile electrons. The electrons aren't stationary; they are moving constantly, and it gives them those unique properties. Okay, so let's kind of dig deeper into the two that we're going to really talk about, and we need to make sure that we know ionic and covalent, and then in the upcoming videos we'll be learning how to draw those. So remember, again, I can't stress it enough, electrons are transferred in ionic bonds, and that's what we'll kind of go through here first. So some physical properties. They've got high melting and boiling points because they are strong bonds. Okay, so keep that in mind as well, that ionic bonds are very, very strong. All right, they are what's called electrolytes. You guys should hopefully have some familiarity with those, things like Gatorade or Powerade. They got all those different electrolytes. All they are different salts that are in solution, and they allow them to conduct electric current when it's in solution. Okay, so they don't conduct current when they're solid by themselves, but when they dissolve and they have those ions that are present, that's when they will be able to conduct that electric current because they've got charges. They are also very hard, so make sure you are familiar with these properties. Again, if you look back at page 4, you've got all those in that summary chart there earlier on. So we will, for the most part, try to classify compounds just by looking at the types of elements that are in those bonds. So we've said already that ionic is going to be made of what? Metal and a nonmetal. Okay, but we can also do it based on electronegativity difference of those elements. So remember, table S is where you would look this up. Okay, and we can look at the difference between the two atoms. So sodium, when you look it up, has got a 0.9 electronegativity value. Chlorine's got a 3.2. When you subtract those, you'd get 2.3. So kind of another way that we can look at it is if you have a greater difference, that's something greater than 1.7, that's typically considered to be ionic. Okay, so the higher the difference, the more ionic it's going to be. So that's one way you could be asked to calculate the electronegativity difference between two atoms, and then from that be able to distinguish, is it covalent or is it ionic. The simple way, the way that we're going to do it most is, do I have a metal and a nonmetal? okay, or those other ones that we listed there with the ions, that's going to be your first go-to, okay, unless you're asked to do it. So keep that in mind with ionic. Let's jump over here to covalent. This again is where electrons are shared, okay, they are shared. So when we get into drawing, we'll talk about how we show that, but physical properties are going to be different because it's shared. These are going to be weaker than ionic because of that sharing. So you've got physical properties, kind of the opposite of ionic. You've got a low melting or boiling point because they have weak intermolecular forces. We'll talk about that in a later video. They are non-electrolytes because they do not conduct current in solution because they don't have a charge. Okay, so there's not going to be a charge here with the covalent compounds, and that's the big difference. That's what gives it those unique properties, why it's so weak. Why it has a lower melting point and boiling point, because you don't have those charges. Think about it. Opposite charges, we know that they attract one another, so they're going to keep it held together a whole lot stronger than just this, sharing that's taking place. So this is where we get with covalent compounds, you get very soft structures versus over here with ionic, they are also called ionic salts. Okay, so salt is not just table salt or sodium chloride, it's any ionic compound. Okay, and those are very crystal, very strong, rigid structures, where covalent compounds, something like carbon dioxide, if you know about dry ice, it will just go right from a solid to a gas immediately because of those forces that, again, we'll talk about later on. So same thing here, we can look at, for the most part, is there a nonmetal plus a nonmetal? That's kind of our first go-to, but we can also look at electronegativity differences as well. So oxygen has a 3.5 value, hydrogen has a 2.1. So when we take that difference, it's a difference of 1.4. So kind of a general rule of thumb. Now there's going to be exceptions to the rule, so don't get hung up on it. That's why we look at metal and nonmetal for ionic, okay, right here, or versus a non-metal and a non-metal over there. So the value here is, if it's less than 1.7, it's generally considered to be covalent. But remember, that's not an end-all be-all. There's going to be some exceptions to that rule. Okay, so the greater the electronegativity difference, okay, between the two elements, the greater the percent ionic character. All that means is the more ionic it is. The bigger the difference, the more like an ionic bond you have. Okay, the closer the electronegativity, I'm just going to abbreviate it as EN, to 0, the greater the percent it is covalent. So kind of on this electronegativity scale that we have down here, this is more your covalent end, and this is more your ionic end. Okay, and kind of somewhere here, that 1.7 is what distinguishes those. Okay, kind of separates it. But remember, this is not an end-all be-all. It's just more of a general guideline. So remember, always look for metal and nonmetal for ionic, nonmetal and nonmetal for covalent. Okay, so kind of just wrap this up here. We can classify a compound as ionic or covalent, like we've said. Look at the elements in the compound. This is your trump card, meaning that's going to take precedent over doing the math. Metal and a nonmetal is going to be ionic. It's an ionic bond as well as an ionic compound. Okay, that means if there's ionic bonding taking place, you have an ionic compound. Likewise, two nonmetals would be a covalent compound. If there's covalent bonding happening, it's a covalent compound. Okay. We can also do the math. Remember, this is secondary. Number 1, this is our big thing we're looking at first. The greater the electronegativity difference between the elements, the greater the ionic character. Okay. And then the closer it is to, the closer the electronegativity is between them elements, the greater the covalent character. Okay, so again, we will get into all the details of the bonding and what's taking place and how to draw those as we go throughout the unit. So make sure you can go through and do practice number 2 here of doing both the electronegativity difference way as well as just looking at the compound.